Okay, so this is the target 9A Pythagorean theorem and the converse of the Pythagorean theorem retake video. So this first one, we're finding the length of this missing side right here. So why don't we go ahead and call it x. And remember, the Pythagorean theorem is leg squared plus leg squared equals the hypotenuse squared. Of course, you all learned a squared plus b squared equals c squared, but I think that's confusing. I always like to call I want to say by what it is, leg squared plus leg squared equals a hypotenuse squared. So now we're going to look at this and we're going to draw an arrow from the 90-degree angle to the side across from it. And that is the hypotenuse. So my hypotenuse in this case is x. And then my other two, my legs are 9 and 12. So I have to square them both. So 9 squared is 81 and 12 squared is 144. The next raised to the second power is just, x squared. So now I'm going to grab out my calculator. Sorry, got to get it going. And I'm going to add 81 and 144. So 81 and 144 are 225, and the square root of 225 is 15. But let me, sorry. 81 and 144 is 225, so 225 equals x squared. I'm going to take the square root of both sides, and I get x is 15. Because the square root of 225 is 15. Yep. Okay. Okay, let's try another one. This one, it says find the length of the missing side if the hypotenuse is 13. So I know that this side is 5, and the hypotenuse, remember that's across from a right angle, is 13. So I'm going to call this side x. Okay, and then remember, again, the Pythagorean theorem is leg squared plus leg squared equals the hypotenuse squared. So in this case, the hypotenuse is 13, so I'm going to square 13, and then I'm going to square 5 and x. So 5 squared is 25, x to the second is x squared, and 13 squared is 169. And I'm going to subtract 25 from both sides, and I get x squared equals 144. And I'm going to take the square root of both sides, and I get x is 12. So the missing side is 12. Okay, so the biggest mistake that people make on the Pythagorean theorem is not putting the hypotenuse in the right spot. So sometimes they just always put whatever x is, they put in place of the hypotenuse. But that's not the way that it works. You always put the hypotenuse after the equal sign in the other two numbers before it. So sometimes your hypotenuse is a letter, sometimes it's a number. Okay? Alright, so in 3 and 4 we have to classify the side lengths as an acute, an obtuse, or a right triangle. It should say right. So remember, if the rules are, if the biggest side squared is largest, it's obtuse. If the biggest side squared is smaller, then it's acute. And if the two sides are equal, then it's right. Okay, so we're going to circle the biggest side, and that's 20. So I'm going to do the Pythagorean theorem. I'm going to say 12 squared plus 16 squared, and I want to know if that's going to equal 20 squared. So this is the biggest side. So it all hinges on this. If the biggest side squared is the biggest, is bigger than these two added together, then it's an obtuse triangle. If the biggest side squared is smaller than these two added together, then it is an acute triangle. And if the two sides are equal, then it's a right triangle. So 12 squared is 144, and 16 squared is 256, and 20 squared is 400. Let me just make sure I did my math right. $16 squared is 256. Plus 144 squared, or plus 144 is 400. Oh, sorry. And 20 squared is 400. So 144 plus 256 is 400. So the two sides are equal, so this is a right triangle. Because the two sides are equal. Okay, number 4. The same kind of deal, so this time 6 is the largest side. So again, I'm going to pause it for a second and insert those rules. I think I can do it. Pretty sure I can. Okay, so yay, I was able to write the rules down again without having to actually rewrite them. So, so again, these are the rules. So 6 is the biggest side, so we're going to square. We're going to do the Pythagorean theorem, so it would be 4 squared plus 5 squared, and we want to know if that equals 6 squared. So we're focusing on that side. This is the biggest side. So 4 squared is 16, and 5 squared is 25, and 6 squared is 36, and 16 plus 25 is 41, I believe. Let me just double check. $16 plus 25, yep, 41. And 36. Now the biggest side, this side, is smaller than this side added together, the 41, so this is an acute triangle. Okay? And number 5, a triangle has side lengths 13, 21, and 30. Your friend says it's acute. Look at your friend's work and describe and correct the error. Okay? So what's the problem here? So it says there's an error, so there's an error, right? 13, 21, and 30 are right, but the problem is 30 is the longest side. So remember that longest side has to be there, and it's not, so that's our problem. Okay? So let's try this again. It should say 30 squared, and we want to know if that equals 13 squared and 21 squared, because it says to correct it, so I need to correct it. So this is how she should have written it, and then remember this is the biggest side. They wrote it this way instead of the other way, but 30 squared is 900, and 13 is 169, and 21 squared is 441. Let me just double check that. 21 squared, yep, 441, and we're going to add 169 to that, and we get 610. So we get 900 and 610. And they're not equal. Whoops. 900 is bigger. So again, I'll go back. I don't want to write the rules again, but if the biggest side squared is larger, then it's obtuse. So the biggest side squared, that's 900, is bigger than 610, so this is an obtuse triangle. Obtuse triangle. Okay? Alright, and that's it for mine. So again, the following problems have to be checked by a math lab teacher, a support teacher, or math lab teacher, a support teacher, or your geometry teacher, and then you can do the retake. Okay, so we have to find the length of the missing side for problem number 1. For problem number 2, we have to find the length of the missing side when we know one side is 21 and it tells us some information about another side. And then in 3 and 4 we have to decide if the triangle is acute, obtuse, or right. And again for 4 and 5. You have to describe and correct any error that you find. Okay? Alright, good luck.